Okay, principle of conservation of energy exercise. Question number 1. Okay, a body of mass 2 kg is released from rest and falls freely under gravity. So means the body is, and then it falls. So means we have a object and then it falls down, okay, and with a distance of 10. So at this point, the kinetic energy is half mv squared. So you have half 2, and because it is released from rest, so it is equal to 0. So the kinetic energy is equal to 0. Okay, and then, does it have a potential energy? You look at the position. Is it up? Is it at the up or down? So it is at the up, di atas, yeah. So potential energy is exists, or else it will become straight away 0. So 2, 9.81, and 10, so you get 106.2. This is at the initial KE and initial potential energy. How about the final KE? So the object will goes down. Okay? So the kinetic energy will be, the final KE would be half mv squared. So half m is 2. V, you're going to find, right, what is the speed. So you just leave it there. Okay, do you have any potential energy? So because it is at the bottom, position is downward, so P is equal to 0. So the total energy, initial to the total energy is equal to the final total energy. So 0 plus 196.2 is equal to V square. This one you cancel off, V square plus 0. So V is equal to 14 meter per. Okay, question number 3. Body of mass 5 kg is released from rest and falls freely under gravity. What is the distance? Okay, the same question, quite similar with question number 1, but just now the question asks you to find the speed. So this one you need to find the distance. So initial kinetic energy is equal to 0 because it comes released from rest, so V is equal to 0. Your initial potential energy, mgh, so m 9.81, the distance is actually the height. So you don't have any height here because you're going to find it. And then for final kinetic energy, half mv squared. So the speed becomes 5, speed is 7 square. So you get 122.5. So final PE. So this one object moves downwards, so 0. So the total energy initial, this one you will get 49.05 H. So 49.05 H is equal to 122.5. So H is equal to 2.5. Question number 5. Okay, find the object of 3 kg projected vertically downwards, so it moves downwards from point A with a speed of 4 the body passed through point B, so it passed point B 5 meter below A. Find the speed of the body of at B. So at A, your kinetic energy is half mv square. So just now for a question 1 and 3, the object is released from rest. When the object is released from rest, so V is equal to 0. Okay, so that's why your kinetic energy is equal to 0. But for question number 5, it has a speed, initial speed of 4 meter per second. So it means that your kinetic energy cannot be equal to 0. So you just substitute your V or your U here, which is your speed, 4. So you will get 24. Okay. How about the potential energy? The potential point A is at is up to B. So potential energy is mgh. So your m is 3, 9.81. Height is 5. So you will get 147.15. Okay, this is at A. Okay, and then at B. Okay, what is the kinetic energy? Half mv squared. B you're going to find. So half T, just leave it v squared here. Your potential energy, okay, the position is at down of is at the bottom of A, so potential energy is equal to 0. So the total energy at A, this is based on the conservation of energy. Energy at B must be equal. So 24 plus 147.15 is equal to 3 over 2 v square. So v square is 114.1. So v is 10.68 meter per second. So this is your final answer. Question number 6. The body of mass 10 kg is projected vertically upward. Okay, that's just now the question is moving downward. Okay, so for question number 6, it is projected upward. Okay, so let's say we have an object 10 kg. This is projected upward from point A with speed 4 meter per second. And then the body reaches highest point and then fall down, passing to a point with 5 meter, so 5 meter, then point B. Find the speed. So this is the question, going to find B. So okay, just a minute. Okay, so please bear in your mind, we're going to find the kinetic and potential energy. It doesn't matter the projectile of the object. Okay, we want to look at the position of the object. Okay? That might matter. We don't want to look at the projectile. Okay, so the same way you're going to find the kinetic energy is half mv square. So 10 kilogram, V is 4 square. So you will get 80. Potential energy is mgh. So 10, 9.81. The height is 5 meter. So you will get 490.5. As I mentioned, we don't consider the height is between object, between both point A and point B. So what is the distance? is 5. So it doesn't matter the projectile. We don't consider the distance between the highest point and B. Okay? It is based on the initial position and the final position. Okay? So for B, the kinetic energy is half mv squared. So half times V am is 10, and then V squared. So you get 5V squared. Potential energy, because the position is at the bottom, so just 0. So total energy at A is equal to the potential to the energy at B. So 5V squared. So V square is 114.1. So V is 10.68 meter per second. Okay, will your answer have been different had the mass be different? So if let's say mass is different. So in this example is 10 kilogram. Okay, 10 kilogram. If let's say we change this 10 kilogram to 15 kilogram, does the total, will your answer be different? So the question is no, because we don't it doesn't depends on the mass. Okay, the speed doesn't depends on the mass. You can calculate, try to calculate. If let's say m is 15, but your answer will be different. Okay, you can check it.